Welcome to Vision Plus and welcome back to this senior for mathematics and complex numbers. We are looking at properties of modulus and we are now on example 3. Example 3 says that we are given two complex numbers z1 and z2. Part A says that we need to find the magnitude of z1 and z2. So the solution is, you can pause the video and try it out. The solution for part A, they're asking for the magnitude of z1, z2. This is the same as from the properties. This is the same as the magnitude of z1 times the magnitude of z2. Here means that the product of z1 and z2. So to apply the magnitude, we are saying the magnitude of the product is the same as the product of the magnitudes. So it needs us to first find the magnitude of z1, which is the same as the square root of x squared plus y squared. This is the same as, for z1, x is the real part of the complex number, which is 5, but we are squaring it, plus y. Y is the coefficient of the imaginary part, which is 1. 1 squared. What is 5 squared? 25. 25 plus 1 is 26. What is the square root of 26? Square root of 26, 5 point something. This is 5.0990 units. This is the magnitude of z1. Then we go on to find the magnitude of z2, which is the square root of x squared. z2, x is 2. So z2 squared plus y 6. 6 squared. What is 2 squared is 4. 4 plus 36 is 40. This gives us the square root of 40. And we place the calculator. 6 squared plus 2 squared is 40. Square root is 6.3256 units. This is the magnitude of Z2. Now going to the question, the magnitude of Z1, Z2. Therefore, the magnitude of Z1, Z2, this now will give us the magnitude of Z1, which is 5.0990 times Z2, which is 6.3256, and then you multiply them. So 5.0990 times 6.3256, and this gives us here 32.2542 units. So this is the magnitude of part B. Part B says that we need to find the magnitude of Z1 divided by Z2. And this property is the same as the magnitude of Z1 divided by the magnitude of Z2. And as you can see, we have the magnitude of Z1 and the magnitude of Z2. So what we can just do is divide. Z1 is 5.0990 divided by Z2, which is 6.3256. And then you press your calculator. 5.099 divided by 6.3256, which is 0 point something. This gives us here 0.8061 units. This is the magnitude of Z1 divided by Z2. And then going to part C. Part C says that we need to find the magnitude of Z1 plus Z2, but we are dividing both by Z2. Now, this is the same as the magnitude of Z1 plus the magnitude of Z2 over the magnitude of Z2. Yes. Now, remember that the magnitude of Z1 plus Z2 is not the same as the sum of the magnitude of Z1 and that of Z2. So simply, for us to be able to get this, we need to first get the value of z1 plus z2. That means we need to substitute for z1 and z2. z1 is 5 plus I, and then plus z2, which is 2 plus 6i, 2 plus 6i. Then if you collect the like terms, 5 plus 2, you shall get 7 plus I plus 6i is 7i. This is z1 plus z2. Now let us get the magnitude of z1 plus z2. This gives us the square root of what is x? X is 7, but we are squaring it. Plus what is y? Y is also 7, and we are squaring it. 7 squared is 49. 7 squared is 49. 49 plus 49 is 98. So here we need to do the square root of 98, which is the same as 9.9.8995995 units. So this is the magnitude of z1 plus z2. Now we need to substitute for this magnitude up there, and we already have the magnitude of z2, which is here. So here we can just say now therefore the magnitude of z1 plus z2 over z2 is the same as the magnitude of z1 plus z2 is here, which is 9.8995, but we are dividing it by the magnitude of z2, which is 6.3256. 1 point something, 9.8995 divided by 6.3256. This gives us here 1.56456498. So here we could just round to 50 units. So this is the solution. But here you have liberty. What you can do is you can first add z1 plus z2, and then you get this answer. Now you get this answer, which is 7 plus 7i, and divide it by the value of z2, which is 2 plus 6i. You work out the division, you get a single complex number, and then you find the magnitude of that single complex number, and you'll be in position to find the same answer as 1.5650.